You know, when you picture a galaxy, you probably think of this perfect, elegant spiral, right? But the universe is full of weirdos. Some galaxies have these oddities hiding in plain sight. And today, we're going to dig into one of those secrets by looking at galaxies that seem to have handles.
All right, so let's meet our main character for this little deep dive. This is Messier 109. It's an absolutely stunning barred spiral galaxy about 50 million light-years away, tucked away in Ursa Major, the Big Dipper. It's beautiful, for sure, but it's also hiding something a little strange. Okay, so look really closely at the center of M109. See that bright bar of stars cutting right through the middle? Now look at the very ends of that bar. See those two little bright spots? They almost look like, well, like handles. So the big question is, what on earth are they? And what are they telling us about this galaxy's, let's say, violent past? So this galaxy, M109, it's so unique that it's actually picked up a nickname, the Theta Galaxy. And you can kind of see why, right? That central bar plus the faint spiral arms wrapping around it, it really does look like the Greek letter theta. A pretty cool call sign to have in the cosmos.
But that's not its only nickname. A lot of people also call it the racing car steering wheel galaxy. And yeah, you can totally see it. That bar with the bright spots on the end, it's a dead ringer. It's actually a really good way to picture the features we're about to get into. Okay, so we've established M109 has these weird handles. But here's the thing, it's not the only one. This is actually a much wider cosmic phenomenon. Right, so in the world of astronomy, these handles have a proper name. They're called Ansae. It's actually Latin for handles, so pretty fitting. The official definition is that there are a pair of symmetric, bright knots of stars right at the ends of a galaxy's central bar. And the key takeaway here is that they're not just some random blobs of light. They're a real structural feature. And this here just makes it crystal clear. On the left, you've got a galaxy with those obvious Ansae. Then on the right, you have a galaxy that also has a bar, but no Ansae. It seems like a tiny difference, right? But it turns out it's a massive clue. And that clue? Well, it led astronomers straight into a major puzzle. Because once they started really looking for these Ansae systematically, they found a pattern that just didn't add up. I mean, they went through huge catalogs of galaxies, sorting them by their shape, and just started counting which ones have antennae, which ones don't. Now, you'd probably expect it to be pretty random, right? But what they found was, well, the complete opposite. So get this. They found that for what they call early-type galaxies, these are the ones with big, bright centers and really tightly wound spiral arms, about 40% of them have Ansae. So in that group, they're actually pretty common. But then they looked at the late-type galaxies. These are the ones with smaller centers and these beautiful, loose, fluffy spiral arms. And the number of Ansae just plummeted, down to basically zero. The rule seemed obvious. Loose arms, no handles. Simple as that. And here's the twist. Here's the puzzle. Our buddy Messier 109, the galaxy that kicked off this whole thing, it's a late-type galaxy. I mean, just look at those gorgeous loose arms. By all the rules, it should not have an SAA. But it does. That makes M109 this really rare exception, a total cosmic rule breaker. And that's exactly what makes it the key to this whole mystery. So how do we solve this? How can M109 break the rules? Well, the answer wasn't found by just looking at flat 2D pictures. To figure this out, we have to start thinking in 3D. This is absolutely the crucial idea. We've got to stop picturing these galaxies as just flat spinning frisbees. The real action, the solution to the Ansae mystery, happens when that central bar actually breaks out of that flat plane and starts moving up and down. So here's what happens. Over billions of years, that big bar of stars can get, well, unstable. As this quote explains, it starts to flop around. It actually buckles vertically. Stars get thrown up, then down, way out of the main flat disk of the galaxy, and this creates a really complex three-dimensional structure. Let's break that process down real quick. Step 1, the spinning bar just gets unstable. Step 2, it starts to buckle, kind of like when you bend a plastic ruler too far, and it pops. And then step 3, all this chaotic, violent motion of stars builds up this thick 3D structure right in the galaxy's core. And if you could see it from the side, it would look like a peanut, or maybe an X.
And this right here is the smoking gun. This graph comes from a computer simulation, and it shows the telltale fingerprint of that 3D buckling event. See that sharp dip in the graph? That lines up perfectly with where the Ansae show up in the galaxy. This is the direct evidence linking those little 2D handles we can see with this massive 3D event that's hidden from view. Okay, so what does this all mean? For a galaxy like M109, what are these little handles really telling us about the grand story of how the universe works?
All right, let's put it all together. These Ansae, these handles, are way more than just a pretty feature. They're basically the 2D tips of a giant 3D iceberg. They're the visible evidence we see of a galaxy's bar violently buckling out of its flat plane. This whole process creates that structure we call a peanut or X-shape. So really, they're signposts of a major chaotic event in a galaxy's life. And M109, it's our rare special window into seeing this process happen in a late-type galaxy, a place we never expected to see it. Really, the best way to think about Enceladus is like they're fossils. They're these perfectly preserved remains of a really spectacular, really violent period of change. They tell a story of instability and reorganization that totally reshaped the galaxy we see today. And it just goes to show you, right? Even in features that astronomers have been looking at for decades, there are these incredibly deep stories just waiting to be told. It really makes you wonder, what other huge secrets about how the universe works are out there, just hiding in plain sight, waiting for someone to ask the right question?